Our lesson for today will be looking at Chemistry 1502. The topic for today is reactions. We'll be looking at substitution, lesson 102. Let us start. There are different types of reactions. We have addition reaction, we have elimination, we have substitution. But one of the most challenging reactions is substitution. That is why I decided that let us start with substitution. And if you can check, most of the organic chemistry mechanism, they involve substitution reaction. Addition reaction is very much simple, but there will be a lesson video whereby we cover it also, and elimination will also be covered. So substitution, let us try to be as much general as we can so that you can understand. We know that when we hear the word substitute, it simply means that taking out something and replacing it with something. We also know that when we say we substitute players during football match, it's when we take out one player and put another one. We actually replace that particular player. So substitution reaction is the very same thing. So let's say we have a substance AB reacting it with C to form AC plus B. You can clearly see that where B was, we actually have C, then we have substituted B with C. Some would say it's a single displacement reaction. Now let us look at this example. Suppose we have our alkyl halide chloromethane reacting it with X, and then we have something like this. So you can see what actually happened. Where we have Cl, we have substituted it with X. So this is another example of substitution reaction. Now in organic chemistry, we have what we call nucleophilic substitution reaction. Remember that the first lesson video we said nucleophile are those particles which are negative, they would like to donate electrons. So you can see the part of that word nucleophile, nucleophilic substitution, it's something that has to do with nucleophile. Now these are the things that are actually happening in a nucleophilic substitution. You should know that a nucleophile replaces a living group from carbon atom. I know that by now you're starting to be confused. What is a living group? We know what is a nucleophile because we know that from the previous lesson video we did mention that a nucleophile is a particle that has a negative charge and donates electrons. Now you want to understand what is a living group. Let us try to explain this statement using a diagram. Let's say we have this reaction. We have our halogen here. Remember, this is an alkyl halide. reacting with a nucleophile we normally donate or indicate the nucleophile using this. To give us, remember that we're dealing with a substitution. This is a nucleophilic substitution, means that we replace a halogen or a halide ion with a nucleophile. So our nucleophile will be here, and then plus our halide ion. So according to the statement, we say we replace a nucleophile, we actually replace a living group with a nucleophile. When we talk about a living group, we are referring to this. This is what we call a living group. It's a group that actually lives. It's a group that is actually replaced by a nucleophile. And then this we refer to product. You might be given this reaction and then they say write down the product, then this is what you actually write, whereby the living group was replaced by a nucleophile. And then we did say that this is a nucleophile, and then this is what we call a substrate, the one that consists of a living group. This is our living group. It's the one that will be having a nucleophile as our product. So in nucleophilic substitution, what is important? Be able to identify the living group. Be able to identify our nucleophile. Be able to write down the product and also represent our living group. Understanding this simply means that we've just started with our first reaction, which I'd like us to talk about, which is the SN2, also known as bimolecular nucleophilic substitution. SN2 nucleophilic substitution reaction is one of the reactions that we have. We have SN1 and SN2. You should know that under SN2, this is only a one-step nucleophilic substitution, and SN2 stands for substitution nucleophilic bimolecular. We know that bi has more or less the same meaning as di, means two. So in this substitution or this reaction, the bimolecular simply means that we have two molecules colliding with each other. We'll be looking at the detail or an example and explaining this bimolecular in detail. So let us start with our first example of SN2. As we go through the example, we also explain the important things that you need to know based on SN2. Let's say we have this reaction. We are reacting iodomethane and hydroxide ion to form methanol which is an alcohol, and iodide ion. This is an SN, actually it's a nucleophilic substitution. Looking at this, we can see that this is our substrate. This will definitely be our nucleophile. This will be our product. And then this will be the living group. But let us break this down into details. So drawing the Lewis dot diagram of iodomethane, we have something like this. Remember, I said what is important is for you to identify the living group from the substrate and also identify the living group in order for you to write it down. So this reacts with OH minus, which is hydroxide. Looking at this, when we focus this in detail, between carbon, let us look at the substrate, between carbon and iodine, which one is more electronegative? We know that our iodine is more electronegative compared to carbon. So if we were to separate or have a bond fusion between the two, we know that iodine will actually move with this pair of electrons because it is more electronegative compared to carbon. And if it leaves with this pair of electron, it will become negatively charged, and then leaving carbon being positively charged. Or we can say this is partially negative and then this is partially positive. The concept of polarization was covered in many lesson videos, so you know what we are talking about here. I believe you do understand. If we have two elements whereby the other one is more electronegative compared to the other one, you should know that it will be more it's actually more partially negative compared to the other one, whereby the other one will be partially positive, meaning that this iodine will pull this pair of electrons towards itself compared to the carbon because of the range of the electronegativity. With that in mind, we can see that this is the living group. Once it leaves this molecule, it will go with this pair of electrons. These bonding electrons will move with our living group. Once it leaves, this will no longer be partially positive, it will be positive. And then this will no longer be partially negative, it will actually be negative. And then looking at our nucleophile, we can see our nucleophile is negative, and then it will be attracted to the positive. Well, according to your knowledge, like I said, this will be negative, this will be positive. It will be attracted to the opposite side. Remember that going back to physics in lower grades, we know that positive and positive will repel. There is a force of repulsion between the two because they are like charges. Positive and negative, they will actually attract. There is force of attraction between the two. And then negative and negative, since they are like terms or like charges, they will repel. And then we have negative and positive, they will surely attract. So with the reaction, we have to integrate that concept here. In order for you to know whether this will bond with this or this will bond with this, you should look at the charges. So if this is negative and this is also negative, there is no way that this will bond with this because they are both negative. So it will actually bond with the positive, which is this carbon here. In SN2, this reaction takes place simultaneously, meaning that as this leaves, this will also bond with this. And we have to be very careful when we write down this mechanism, because the manner in which we orientate or represent our drawing is very much important. We cannot just draw as we like, we have to follow few guidelines. So in this case, if this our living group, it's actually leaving the molecule, you should know that it will not be very far from this. Our nucleophile cannot attack or bond with this by moving past our leaving group, because remember that we said we have negative and negative, so it cannot pass through here and go to our positive ion there. And you should know that this is a electrophile. Remember that in the first lesson video we said that electrophile would like to receive a pair of electrons. So what happens is that this nucleophile will attack it from the back. Then if you write it like this, this would actually be the most accurate one. This is the leaving group, and then our nucleophile will be here. So this nucleophile, as our leaving group is leaving, the nucleophile will attack from the back. Remember that it will try by all means to avoid this because they are like charges. They both have negative. So this process, it happens simultaneously. As this attacks, this leaving group also leaves. That is one of the properties of SN2 reaction. So the product of this, we are going to have bonded with our carbon plus the leaving group. So once we identify this, this will be our nucleophile, this will be our substrate, this will be our product, this will be the leaving group. Let us look at another example. Suppose we are reacting sodium methoxide one bromobutane Let us go through the mechanism. You can pause the video if you've understood the first example. Play the video to verify the answer. Now in this case, we can see that this will be our nucleophile, I mean. And then this will be our substrate. But you should understand that not all this nucleophile will take place or will take part in the chemical reaction or in the substitution reaction. As we look at more examples, we are going to have a practice question whereby we look at more examples. You will see how we use this nucleophile. So in this case, we have to break this down. We know that sodium is from group number 1. The oxidation number of sodium is 1 plus, meaning that the oxidation number of these will be 1 minus. So this will actually be the nucleophile that will take place in the nucleophilic substitution. So let us draw the Lewis diagram for this. If we had to write this, we can simply write it like this. And then we have our oxygen having that negative charge. And drawing this, Remember, this is at the back, this is at the front, and then we have our don't be confused, this carbon is actually this one. That is why it has two hydrogens, and then this part is this one. And then we have our living group here. So what will happen is that during the reaction, we know that the nucleophile will attack. It cannot attack from the front, it will attack from the back, because we know that this is partially negative, this is partially positive. So negative and positive, they will attract each other. As it attacks, the living group will leave the molecule. We have what we call a transition state. It's that step whereby the living group leaves, at the same time the nucleophile bonds with that carbon. This dotted line simply represents the breaking of the bond between the carbon and the living group. And then we also have dotted lines when the bond forms between our nucleophile and that particular carbon. This is what we call a transition state. And then once this happens, we are going to have something like this. Remember that the first thing that happened is that we had this breaking with this. So we have sodium plus and our living group as Br. There are many things that we should consider when we look at this, because look at this structure. You can see that our hydrogen here is at the back, this one is at the front, but after bonding with our nucleophile, you can see that it's no longer at the back, but we have something like this. And also look at the orientation of this part here and also this one. There are many things that we should check. In the next lesson video, we'll start with more practice examples looking at the SN2 reaction and representing the mechanism step by step with explanation. That's it for this lesson video. This is Wabula SJ. Thank you very much.